In this video, we're going to talk about writing hypotheses and introduce the ideas of hypothesis testing. A hypothesis is a statement or claim regarding a characteristic of a population. Or another way of saying it is it's something that we believe to be true about a population. And we want to test our hypothesis to see if we are right. So in the real world, the process that we would go through is we would make our claim, and then we would collect sample data. We would use our sample data to test our claim. In the problems we're going to be doing, we're going to be given the sample data, and so all we're going to have to do is step 3. There are two types of hypotheses that we use in hypothesis testing: the null hypothesis and the alternative hypothesis. The null hypothesis is the statement of equality. It's the statement that the value of a population parameter is equal to our claimed value. And we're going to be working with two different types of parameters here, the mean and the proportion. Remember, we would use mean if we're working with quantitative data and proportion if we're working with categorical data. And the null hypothesis is the statement that we are testing. Null hypothesis is assumed to be true until evidence indicates otherwise. So it's kind of like the court system. You're presumed to be not guilty unless there's evidence, enough evidence is found that you are guilty. So we either reject the null hypothesis or we fail to reject the null hypothesis. Those are the only two options in hypothesis testing. We do not accept the null hypothesis, and we do not accept or reject the alternative hypothesis. Again, it's either reject the null hypothesis or fail to reject the null hypothesis. The alternative hypothesis, there's two ways that you could see this: HA or H1. The null hypothesis is written H0. The alternative hypothesis is the claim that the population parameter is different from the null hypothesis, and it will contain a symbol of less than, greater than, or not equal to, depending on the situation. Null hypothesis always contains an equal sign. So when we are doing a hypothesis test, we begin by assuming that the null hypothesis is true, and then we look at our sample data and see if they provide evidence against the null hypothesis. If the evidence is strong enough, we reject the null hypothesis, and we can say that we have evidence for the alternative hypothesis. We can't prove that the alternative hypothesis is true. All we can say is that there's evidence supporting the idea that it is true. So we're going to practice writing hypotheses here first. So it says to write the null hypothesis and the alternative hypothesis for each. Number 1 is, according to a Gallup poll conducted in 1995, 74% of Americans felt that men were more aggressive than women. A researcher claims that the percentage of Americans that feel this way is different today. So the first idea is that this is regarding a population proportion. 74% is a proportion. And the other thing is that the researcher claims that the percentage is different today. Now, the researcher isn't saying that it's higher today or that it's less today, and that's very important when we're writing our hypotheses. So our null hypothesis, H0, is always the statement of equality. And we're going to use P when it's a proportion, and we're going to use mu when it's a mean. So our null hypothesis is that the proportion of people who feel that men are more aggressive than women is 74%, or is equal to 74%. Our alternative hypothesis is that it is not equal to 74%. So we would use the not equal symbol. Number 2 says the packaging on a light bulb states that the bulb will last 500 hours under normal use. A consumer advocate would like to know if the mean lifetime of a bulb is less than 500 hours. So again, we're talking about a mean here, so I'm going to use the symbol mu. And my null hypothesis is that the mean is equal to $500. Always use an equal sign for the null hypothesis. My alternative hypothesis, now in this case, The researcher, or the consumer advocate, would like to know if the mean is less than 500 hours. So for my alternative hypothesis, it's going to be mu is less than 500. And so we have names for these when we have the less than, equal than, or greater to. If our alternative hypothesis is a not equal hypothesis, then that gives what's called a two-tailed test. If our null hypothesis is less than, the parameter p or mu is less than some value, that's going to be what's called a left-tailed test. And if our alternative hypothesis is greater than, then that makes what's called a right-tailed test. So now we're going to determine the null hypothesis and the alternative hypothesis and state whether the test is two-tailed, left-tailed, or right-tailed. So number one is the proportion of drivers who admit to running red lights is greater than 0.5. So my null hypothesis is that the proportion is equal to 0.5, and my alternative hypothesis is that it is greater than 0.5. And since it's greater than, this is going to be right-tailed. For number two, the mean amount of Coke in cans is less than 12 ounces. My alternative hypothesis, or my null hypothesis, is that the mean is equal to 12. Remember, null hypothesis always has the equal sign. Alternative hypothesis is that it is less than 12. And since it's less than, that makes it left-tailed. Number three, the Medco pharmaceutical company has just developed a new antibiotic for children. Among the competing antibiotics, 2% of children who take the drug experience headaches as a side effect. A researcher for the FDA wishes to test the claim that the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So my null hypothesis is that percentage or proportion is equal to 2%. If it's a percentage, we have to convert it to a decimal. And my alternative is that it is greater than 2%. And since it's greater than, this is right-tailed. And lastly, the Blue Book value of a used 3-year-old Chevy Corvette is $37,500. John wishes to test the claim that the mean price of a used 3-year-old Chevy Corvette in the Detroit metropolitan area is different from $37,500. Notice this says different from, so he's not claiming that it's greater than or less than. So my null hypothesis would be that the mean is equal to 37,500. My alternative hypothesis would be that the mean is not equal to 37,500. And since it's not equal to, this would be 2